23 years ago today, I want you to cast your mind back, 23 years ago today, the way we viewed space changed forever.
Hours of tension finally released.
This is Mission Control Houston. PDRS officer in the control room here confirms the Hubble Space Telescope is released.
This was the picture that NASA managers all over the world were waiting for. The Hubble Space Telescope, free from the space shuttle, floating in orbit, 381 miles above the Earth.
And we have wing motion.
Okay, Houston, we see motion.
Then, the robot arm was detached from the telescope, and the shuttle moved slowly away, opening the door on a 15-year lifespan for the most expensive science project in America's history. The shuttle is now keeping its distance from the space telescope as scientists make final adjustments before we get to see the clearest pictures ever seen in the history of astronomy.
50 trillion miles away, this is Sirius A, the brightest star in the night sky. Stargazers have watched it since antiquity, but this new image penetrates through its intense glare more deeply than ever before. It comes from the Hubble Space Telescope. Astronomers' biggest problem has always been the light from Sirius A, obliterating light from its tiny companion Sirius B, just a speck here. This white dwarf is roughly the size of the Earth, but the new observations show it is incredibly dense. In fact, there's so much matter in such a confined space that its gravity is 350,000 times greater than the Earth's.
Few things can take us further into the past than the Hubble Space Telescope. Orbiting nearly 600 kilometers above us, frees it from the distorting effects of the Earth's atmosphere.
We can see things that are approximately 10 billion times fainter than you can see with the unaided eye. We could easily see the light from a firefly at the distance of the moon.
The result of this is an image that can take us back more than 13 billion years.
Wow, almost when I was born. That's the Hubble telescope being launched by NASA 23 years ago, and a sense of how it's helped scientists learn more about our known universe. Within a few years, scientists in Chelmsford were working to make it even more powerful. So there's the connection. In 2009, the telescope was upgraded with a new camera containing imaging sensors designed and made by e2v Technologies, which is in Essex, of course. John Kemp is e2v's marketing manager for space and scientific imaging. What a great job, John!
It's good. I nearly had rocket scientist on my birth certificate for my daughter. They didn't quite understand what we did.
Nearly there, weren't you? Now, look, what is an imaging sensor to start with? What do you do?
So we're doing the core technology that detects light, turns into an electrical signal that then the space mission, whatever it is, can use. So it's not dissimilar to what's in your handheld camera or mobile phone, but much bigger, much more expensive, much higher quality.
So it detects the light, and that little clip there, 10 billion times fainter than the human eye can see.
Yeah.
It's incredible, isn't it?
And that was before the e2v difference. So you can see images from before the e2v sensors were put on the Space Telescope and afterwards, and there are galaxies and stars you just could not see before we added that on. So that order of magnitude improvement from us in Essex.
And I gather it took 15 years to develop this new imaging sensor for the Hubble.
Yeah, we typically, for the big space programs, and we worked on a number, we spend a long time talking to the scientists and the European Space Agency, NASA, to make sure that we can do what they want. We'll work with them to challenge which laws of physics need to be got closer to. Lots of R&D, and then a long time making the sensors, and of course proving their work. Normally when a space sensor is launched, there's no fixing it once it's up, you can't replace it, so a lot of time spent on test qualification.
Well, I'm fascinated because, all right, 2009 we had the shuttle, but of course we haven't got the shuttle anymore, have we? So, I mean, what are they going to do in the future?
So there are all sorts of automated systems being looked at. There are also some, actually several space agencies are looking at how to get manned missions up again. Europeans, Indians, Chinese, Americans all have different ideas on that. Actually, last time they went to the Hubble Space Telescope, they were concerned that at some point it's going to decay its orbit, it'll drift back towards Earth, to control that, they didn't have a solution, so they've put effectively some rigging onto it. They'll be able to send up an automated mission to grab hold of it and make sure it lands in the right place.
No, really, that's incredible. Could NASA have got those sensors in the US?
They couldn't, and that's why they come to us for other missions as well. There are other image sensor suppliers, but not to the quality and not to the reputation. You know, they need to know these things are going to work, and we're the people they trust to do that. That's
incredibly prestigious for Essex, isn't it, and for e2v?
It's fantastic. It's great. We've got a great dedicated team working on this stuff, and I'm sure when they hear this and when they see the science successes, it's really nice and enthusiastic to say we had a part in that.
And I'm, as I was saying earlier on, I'm doing a sort of conference this afternoon about increasing business in Essex and getting more jobs here and so on. So what effect has this had on high-tech jobs in our county, and what will it have in the future?
We've got a big growth programme underway. We're doing more and more of these space programmes. We have some regional growth funding from the government, effectively, and we're increasing by about 50% the people that are working on this over the next 3-5 years. So we're employing more and more people to work on this.
So highly skilled people
yeah.
coming to our county?
Yeah, exactly. Coming in from outside. And also, you know, there are some people that come in. We spend a lot of time training local people into the roles as well.
Right. And what have we learnt from Hubble and through Hubble?
I think probably the standout scientific success is measuring the age of the universe. So before Hubble was launched, there was people knew it was 10 to 20 billion years old or so. They now know it's 13.77 billion years old, so much more accurate. And Hubble's being able to see further and further out, and therefore into the past. It's got back to something like 500 million years, which, to compare it to a human life scale, we're just about seeing the universe getting out of nappies, effectively, that far back.
That's incredible. What was happening at, how old is it, sorry?
500 million years old, so, billions of years ago.
Right. Right, I wonder what was doing, yes, all those billion years before that. Anyway, that's another matter, isn't it? So, what is there still to learn about space?
Well, the big challenge at the moment, and the big emphasis for Hubble and also some other missions that are taking off, is all about dark energy, which you might have heard of, and dark matter. So, actually, Hubble went up and found out the universe was expanding and they could measure the rate. Now they're trying to work out why is it expanding. We know gravity pulls things together, yet the universe is accelerating away from itself. We know it's something we can't see, and so Hubble's trying to measure that and get a grip as to where to look for the next missions, really, to identify what is this force that's pushing things apart in the universe.
Right, and you're working on this?
Yes, there's a future European mission called Euclid, which its primary goal will be to identify what is this dark matter, dark energy, where is it, and how do we understand what it's doing.
What are we going to gain from this? Because, you know, we've been talking, this is sort of sublime to the ridiculous in many ways, isn't it? The other way around. Because people are having to go to food banks because they have no money to buy food, and yet we're talking about measuring the age of the universe, and in two different. You know, you commented on that, didn't you?
Yeah, I applaud all the guys that work on food banks. I think it's obviously very crucial.
But what are we going to get out of it in practical terms to make our lives better?
So I think that there's the broad, Victorian explorer thing. We want to know more, and our demand for curiosity, and as humans, we always want to know more what's going on with our neighbours, but also beyond that. There are some real-term impacts from big science projects. So things like the MRI scanner, which people might have used in hospitals and used to great effects. There's a good argument to say that wouldn't have happened if big science projects, for ethereal reasons, hadn't happened first to develop the technology.
Right.
So there are real-world application spin-offs from all this.
And also, I was getting a bit confused earlier on because I was talking about these 2 planets that were found last week, and that was by Kepler.
That's right.
And you're part of that as well?
Yeah, Kepler's a huge camera. It's almost 1 billion pixels. So if you think you might have maybe a few megapixels in your camera, it's almost 1 million times, 1,000 times more. And that's found a large number of Earth-like planets. Now, Earth-like is a pinch of salt, about our size, about our temperature. And that, coupled with the Mars missions, we've seen the Mars footage, again, we're involved in that, raises big questions about life out there somewhere, and lots of scientists and philosophers thinking about that.
And so we've got Kepler at the moment, but in the future there's going to be another one, you said?
Yes, the European Space Agency getting ready to launch Gaia, which is bigger again powered by e2v sensors. That will have a huge capability to look in directions that Kepler can't see, and so it will find many, many more Earth-like planets again. as well as challenge laws of physics. They'll be looking at Einstein's laws and just revisiting those, checking out the constants that scientists believe are there for that as well.
And without you lot in Essex, that couldn't happen.
That's correct, Dave.
Wow. John, thank you very much indeed for coming in today. John Kemp there, e2v's marketing manager for space and scientific imaging. So there you go. Now you know what's happening, one of the many things happening right here in our county.